Ladies and gentlemen, let me begin this third introductory lecture also with an obvious statement, namely that the achievement reached by quantum chemistry throughout the 20th century are simply astonishing, of an obvious historical proportion. And they've been so diversified to virtually enter in our everyday life. Everything that we touch nowadays is a result of a magnificent discovery by the chemists of the 20th century. After having said so, it is my duty and my conviction that I have to bring to the attention of my colleagues that we are far from achieving final chemical knowledge. Therefore, to push forward, to identify the next step in the scientific evolution of our notion in chemistry, we have to identify the limitations of the basic theory used in the 20th century chemistry, which is quantum chemistry. Now, the moment I mention the limitations of quantum chemistry, a number of fellow chemists they feel offended, and such as the hint being that they feel like their discovery are kind of demeaned. No, my intent is the opposite. My intent is to instead to indicate that that fantastic, outstanding discoveries were made by chemists throughout the 20th century, despite the limitations of the basic theory, which is quantum chemistry. Being an applied mathematician and a particle physicist by inspiration, I can also tell that quantum mechanics has been immensely more helpful to particle physicists than quantum chemistry. Quantum chemistry has been helpful to chemists. So rather than offending any fellow chemist, no, I want to emphasize the power of their intuition of achieving such monumental discoveries without a quantitative underlying process. Now, after having said so, I have a strong statement to make. It is my personal opinion. I do not expect fellow scientists to agree. Allow me to express it for whatever its value. It is after studying the issue for some 50 years. It is my deep and documented belief that quantum chemistry is nowhere exactly valid in the chemical world. Let me repeat this strong statement. While, as I indicated, special relativity is exactly valid under certain conditions, those were stated by Einstein, not Einstein followers. Similarly, the case quantum mechanics is exactly valid on the conditions stated by Dirac, Heisenberg, Schrödinger, the founders, not the followers, etc. So there are conditions of exact validity. It is my opinion that there exist no conditions in the chemical world for which quantum chemistry is exactly valid. This is the main objective of this lecture. So give me a chance to illustrate my point, hoping that this will initiate a scientific debate, which means with publications in referee journals. Everything that I have to say has been published in referee journals, and I encourage opposing views. Also, everything I have to say is available in free PDF download in the World Lecture Series in the section for the Lecture 1C. Very well, I have organized this lecture into 5 different parts. Parts 1, I would like to identify the limitation of quantum chemistry for the molecular bonds, for the valence bond. Part 2, I would like to identify the limitation of quantum chemistry for the representation of molecular binding energies. Then I would like to identify in the part 3 the limitation of quantum chemistry for chemical reactions, which is the central topic of this entire series of lectures. Then I would like to identify the limitation of quantum chemistry for living organisms. And finally, I would like to close this lecture with a few remarks regarding the limitations, which are substantial, of available analytic equipment. Very well, let's get started with part 1. Dear ladies and gentlemen, again I have to start with a strong statement. I beg you for leniency. I am not expecting you agree, but at least consider my 50 years of meditation and thinking on the subject. The strong statement is that I have never accepted the 20th century notion of valence, beginning from my studies in the PhD courses at University of Torino in the mid-60s. And the reason is that I consider the 20th century notion of a valence a pure nomenclature without a quantitative scientific background. Let me make the statement. I consider the notion of a valence or molecular bond according to quantum chemistry pure nomenclature without quantitative scientific background. Why so? Well, because for me, for a notion of a valence to be really quantitative, first of all, I need the equation that represents the attractive force between valence electron pairs or valence electrons orbiter. I need the equation that identifies the force. Until the equation is identified, my entire conception of a scientific process is like missing the foundation. After identifying the equation, this quantitative treatment has to prove that that force is attractive. Now keep in mind we're talking about identical electrons. Identical electrons repel each other according to quantum mechanics. So you start to see the difficulties for passing from a nomenclature to a quantitative scientific process. And finally, the 1 and 2 are not enough. After proving the existence of an attractive forces with equation and proving that it is attractive, that quantitative process has to be in agreement with the experiments. The solutions, or at least a preliminary solution of those quantitative issues, has been a primary motivation for building new mathematics and then building a new physics, hadronic mechanics, and then passing only at the end of this long process, passing to build a covering of quantum chemistry known as hadronic chemistry. Notice that quantum chemistry was built only after first the mathematics of quantum mechanics, Hilbert space, etc. And then quantum mechanics had to be built, and then quantum chemistry could be conceived. Well, we had to repeat the entire process. That's why it took, ladies and gentlemen, it took decades. However, this process has been completed now and is available, published in referee journal, books all over, in all developed countries, available for all young minds with a minimum of scientific curiosity. To begin, let me bring your attention on the mystery of the valence bond. For this reason, I have selected in the introductory part of this lecture, as you may have seen, a view of the temples in the Far East that gives precisely an impression of mystery to us from the Western world. I also selected an appropriate music by Albinoni to illustrate and again to convey this sense of mystery. Why mystery? Well, this is an hydrogen atom. The hydrogen atom is a perfect sphere, as we know. Perfect sphere because of rotation due to temperature, also as well known. The point is that all total electromagnetic characteristics of these atoms are zero. The total charge is zero, total electromagnetic and magnetic, everything is zero. So the big mystery, how nature makes the miracle of bonding together two hydrogen atoms very tightly, because the binding energy of a hydrogen molecule is 110,000 kilocalories per mole. It's very substantial. So how this miracle is done? Well, this is a very deep question, which is at the very foundation of quantum mechanics, has been unable to solve it in any quantitative way, in my knowledge. So therefore, hadronic mechanics address this issue and is a central topic of research for us. Basically, in view of this mystery, the notion of valence essentially correlated the electrons in a rather weak way.